Okay, so welcome everybody to DevOps Tools for Java Developers. My name is Stephen Shin. I run the developer relations team at JFrog, and I'm going to be joined with my co-speaker, Melissa McKay. You want to introduce yourself, Melissa?
Hi, good to be here, everybody. Um, I am a developer advocate with JFrog. Um, haven't always been a developer advocate. In fact, that was only for the last 6 months or so. Prior to that, I was a developer and spent almost 20 years working on various projects in various languages.
See,
So,
I think that's not true. You've been an advocate for developers for a while.
well, okay. Something I like to do on the side, and then finally decided, hey, I want to do this full time.
Cool. And we're going to talk a little bit about how you can do your DevOps implementations better, what sort of tools you need as Java developers to be successful. And you don't actually have to worry about taking notes or doing screen shares, because we've done all that hard work for you with this link here. So we have a page at jfrog.com/show notes, or this QR code will take you directly to the page, and it has all the slides. When the recording is available, we'll post it there as well. And then we have a raffle where you can win a GoPro Hero 8. I used some of these cameras on my motorcycle tour, but they didn't look that cool. Maybe that's a newer model. Okay, maybe I should enter the raffle and get one of those. Oh, we're co-authoring a book as well for O'Reilly called DevOps Tools for Java Developers. So that's super exciting. How does it feel to be on your first book project?
It's pretty amazing. It's going to be a good read, I promise.
Okay, so we're going to start by scaring everyone into why you should actually care about this, because unfortunately, security vulnerabilities and not being able to release software quickly has become the new oil spills of the software industry. And if you think back to classic oil spill examples, like this is the Taylor Energy oil platform, which is still leaking oil to this day. I think this is one of the single largest ongoing oil spills in the history of the world. And it was started in 2004 by Hurricane Ivan. It leaks 300 to 700 barrels per day, and they spent an initial cost after the oil platform was knocked over of 435 million just in the initial cleanup, which didn't even stop the leaking fully. And if you look at this from in terms of software, we all rely on open source software in our projects. 99% of enterprise projects and 75% of those projects contained at least one vulnerability. So we're all relying upon libraries where we have huge vulnerabilities, and we're putting both our customers and our businesses at risk. And on average, there were 82 vulnerabilities per code base in open source projects. So just like oil platforms can cause a lot of damage for oil industry and the environment, software vulnerabilities cause a lot of damage for the industry. And the classic example of this is the Equifax breach, where it took them 2 months to fix an Apache struts vulnerability. And in the process, they exposed 143 million American consumers' data to the attackers who stole the data.
Wow, Steve,
And
this is pretty
go ahead.
incredible. I loved your bringing up the oil spill stuff. It's a pretty horrifying physical reality, but I mean, there's a lot here in software that we need to take seriously as well.
Yeah, I mean, we don't all work in on data sets or in businesses which are as mission critical as for example, holding all the security data for all the citizens of the US. But if you think about it, for your company, having a big breach can often be catastrophic, right? Like it can be the difference between being successful as a business and going under. And a lot of it has to do with the stuff we do. We deploy software, we're responsible for security. And if you're not doing those things, if you don't have good processes for deployment, you're putting yourselves and your company at risk. Equifax if there was kind of a silver lining in the Equifax blow up, actually it's assumed that none of the data which was stolen was actually used for nefarious purposes. And part of the reason why that's assumed is because it never surfaced. Like there never actually surfaced lists of consumer information on the black market. But also the U.S. government indicted the Chinese military this February as being the attackers. So they actually levied charges against a Chinese military hacker group. So the thought here is that it wasn't for profit. It was a government attack to get data which they could use against covert operatives or some sort of spy mission, thing like that. So good for the American public, not good if you're a spy for the U.S. But I think part of the point here is we all use software, and even devices like sitting around you have to be updated and have to be secured. So think about it: your car, if you have like one of the fancy smart cars with consoles like the Tesla, or if you're doing Android Play or Apple. What's the Apple car thing? Car. They both have pretty popular car navigation systems now. Smart TVs, your smartphone, even your fridge might be smart enabled and tell you when you're running low on groceries. And all of these need software updates. And so the question is, do you trust the software update? Would you actually want to update your device? And I think this is kind of the thought process that we all go through as developers. So an update becomes available, and first we think, do we actually want the update? Does this have a feature we need? And hopefully, your fridge having an advanced new feature where it downloads shopping lists from Amazon or something is good, and you want to upgrade. Is it risky? And then if it's not a risky update, if it's a minor update or a patch or something, you might just consider updating just because. But if there's any risk, if it's a major upgrade, you might want to think twice. Do you trust it? And again, this is kind of trust in the company, trust in previous issues with updates. And I think all of us have had classic update fails with your phone, iOS or Android updates where it just updated and it bricked your device or somehow messed up something application you're worried about. Do you have any classic fails on a personal level, Melissa? Oh, you're on mute. I can't hear your mic right now.
I'm sorry. Thankfully, I don't have a car yet, but that would be a big concern for me. Updating my car as I'm driving down the road. We might want to take that one a little more seriously.
Mike Gascoigne, who did all the he did all the technology for the F1 race cars, and they had an issue with some of the control chips on the race cars, which essentially they had data logging built into the chip. And when the log buffer filled up, it was supposed to cycle and overwrite the logs so that it wouldn't overflow. And they screwed up the algorithm, and rather than overwriting the logs, it started overwriting the entire memory from a null register from 0.
Yeah.
And it was tested live in a race, unfortunately, because that's when they actually had enough data to overflow the buffer. And 2 cars suffered from this. One car, when the accident happened, the driver had the gas pedal down, and that car crashed. Unfortunately, the driver was fine. The other car, the gas pedal was up because he started 10 seconds later, and his car just went to a halt, so he was okay. But two do not completes in the same race, do not finishes in the same race, and basically it lost them a lot of points for that season based on a software error. Okay, so do we trust it? Of course we don't, because we're software developers and we know software is buggy. The next question is, can we verify it? And that, of course we can verify it, but it's expensive. And the question is, how expensive is it? And as Java developers, I think a classic example of this would be updates to OpenJDK. So Mark Reinhold announced at DevOps Belgium 2017 the new release cadence for 6-month releases, which is awesome. We're finally getting like smaller fine-grained releases on a regular basis from the JDK. And you can get the latest version of OpenJDK every 6 months. They've been really good on hitting the timings on releases, which is all great. But with the frequency of releases and kind of the history of large Java releases and backwards compatibility, as developers, we know there's a lot of testing involved. And actually, the release which requires the most testing is the one which kicked all this off, which is Java 9, which introduced modularity. So that introduced a whole bunch of backwards incompatible fixes unless you're in compatibility mode for not using modules. And in general, the libraries you depend upon also have to be modular aware to fully use the features. So a lot of people have trouble getting past Java 9. So for our audience, we'll be in chat. So here's the quick poll for you. How many of you guys have actually upgraded beyond Java 8, and which version are you using? Okay, so we'll reveal the data from Sneak survey earlier this year. So here's what they found out about upgrades. So unfortunately, the majority of people were still on Java 8, 64%. Some people Java 7 or lower. Apologies for you guys that you're somehow not able to upgrade. Actually, a lot of folks have made it to Java 11, which is the current long-term support release, which is awesome. And
That one's really,
of course,
that one's really good too. I just want to mention that, I mean, a lot of containerization improvements were made with Java in 11, right? So it's good to at least get to that level.
Yeah. I think if you're doing any production software, it's the release to be on. If you can do it from a dependency standpoint, if you don't depend on things which still require Java 8 for some reason. And we'll see how our audience does. When I ran this poll in India, I did the keynote at the Great India Developer Summit. It was almost precisely this. I think it was like 65% on Java 8 and about 25% on Java 11. So it was actually almost these percentages like last month in India when I asked folks. And essentially, this is kind of the challenge for us as software developers. Is this is the decision-making process we go through. So, do we want it? So hopefully the answer is yes. Is it risky? Well, yes, we know it's risky. Do we trust it? Yeah, not really. And we can't trust it because we have to do the right thing for our companies, and that's why I have unit tests. That's why we want to make test suites. And so we have to verify it. And I think for a lot of folks, this is the challenge of doing upgrades is you have to do potentially costly upgrades to get from version to version. So I think another classic software failure in our industry is Knight Capital. So Knight Capital is a company which does trading. They were part of a new trading system which was being rolled out, and they redesigned their system to support a new style of trading, put it in production that morning of the opening, and immediately upon when people started executing trades, they have 10 million. They were losing $10 million per minute on erroneous trades being entered into the system. And so they quickly tried to scramble and figure out what was wrong with the system. The way their system works, they had 8 servers which were handling the load. And they assumed that they had an issue with the servers on the deployments where they deployed bad software. So they rolled back all of the servers. And when they finished rolling back the servers, actually it amplified the problem and it got worse instead of better. And they finally figured out what was wrong, but the problem was the failure in deployment was they had manual processes for rolling out deployments to their servers, and they made API changes. They reused an old API. So all of the clients were using the new API. 7 of the 8 servers were using the new API, and the 8th server, which was running the old code, was the one which was executing erroneous trades. And when they rolled back, all 8 servers were executing the same erroneous trade. So they actually found the problem, they diagnosed it. It took them about an hour, and it cost them as a company $440 million. Basically, they executed erroneous trades, 379 million shares of 154 different stocks. And they were able to roll back some of this, some of the larger trades, but because of trading regulations, a bunch of this they just had to take as a loss as a company. Unfortunately for Knight Capital, this basically was the end of them as a company. So they took a huge loss. They ended up having a merger at the end of the year, and a lot of the executive leadership didn't stay with the company. So it's kind of a sad story for the company, all caused by a simple deployment failure. So this is kind of the challenge of updates, is making sure they're secure, making sure they're tested, having good automated infrastructure for it. And just one more example to kind of underscore this is Cloudflare, which I think we all rely upon for the websites we visit. A lot of our businesses use it for being a proxy for our information, or CDN for information. And they're such a critical piece of the infrastructure of the internet that a failure at Cloudflare affects the whole internet. They can take down a whole section of the internet just with simple mistakes. And they've had multiple failures, but one of the most catastrophic ones that happened recently was caused by a erroneous regular expression. Actually, this is the exact regular expression, which was deployed into production. And this regular expression basically threw all of their servers into resource starvation loops, and took down their entire infrastructure for the span of about half an hour. And so I'm sure the folks in the audience now are staring very intently at this regex to figure out what's wrong with it. So I'll give you a hint. It's this particular portion of the regex expression that's highlighted in red, and you can basically ignore the question colon parentheses, because that's a capture group. So it breaks down to this relatively simple regular expression, which is a double wildcard match. And the problem with this is regular expression engines, which are not designed to short circuit complex operations, basically have to do backtracking, and this becomes an exponentially hard problem for them to solve the longer the string which they're searching. So if you just give it small search strings, it's fine, it executes fast. If you give it a very large search string, then it does backtracking, which just turns into such an exponentially cost-intensive operation that you basically throttle your machine on the CPU. And so anybody who figured this out by looking at the original regular expression, you're a genius. But for the rest of us, if you're looking at the regular expression you wrote yesterday, you probably just can't understand it at all, because it's so obtuse and hard to understand, and you really need good tests. You need good security, and this is how you avoid critical problems like oil spills. And of course, we have good technology to solve not only software problems but also oil spills. So just to close out our earlier example with the Taylor Oil platform, they ended up doing some more research into this and figuring out exactly where the main oil plumes were coming from. Back in 2018, a group called the Covilon Group put together a relatively well-engineered oil containment system, which sits on top of those plumes. They use a ship and they gather the oil. They have a pipe that goes up and they rotate ships to then collect the oil. And they've been able to get the flow rate down significantly. So this has been able to mostly stem off the oil leak, although it is a fairly resource intensive operation to continually siphon off the oil with boats above. So hopefully we have equally good automation for our DevOps infrastructure as Java developers, and can not only solve having good source control as a single source of truth, doing continuous integration. So we're building and testing on all of our check-ins. We need package management so that we can actually understand the binaries, trace any defects right back to the original package which caused the problem. Have good security scanning so that we can actually uncover any security issues, and then do continuous deployment. And we have a platform for this at JFrog that does all of this. And actually, we're most well known for Artifactory, which is our binary package management solution, which a lot of Java developers use. And I think Melissa is going to tell us a little bit more about how we can integrate this with our IT value stream. So just to make this cleaner, I'm going to let you share your screen instead, Melissa.
All right.
Yep.
All right. So I'm just going to talk a little bit about some things that that maybe you haven't really stepped back and thought about in the past, having to do with your whole value stream, everything that you do from the beginning of your coding all the way into production. The most important things that we think about, we do tend to focus a lot on the actual product, actually, what is actually out there in production, what is running right now. And we're worried about, attacks, external attacks. We're worried about the quality of that service, the reliability, that kind of stuff. But one thing that we often don't step back and do is actually, as a team, come together and talk about what your values actually are. And I think that's a really important thing to start with. We all want to get it out there fast. We all want to have a service that is reliable, that is quality, that is foolproof, isn't going to fall down because of some security hack that is well known that we just didn't update, all of that stuff. So I was introduced to this exercise a while ago. And as a dev, you're kind of, you can be separated from a lot of this stuff. There's a lot of decisions being made outside of your team that you may not be aware of. And these are things that are important. And if there's one thing that you take out of this talk, the most important tool that you can have is communication and understanding the big picture, avoiding silos. Usually we talk about silos as, within the team, avoid silos within the team. But I'm talking about silos from the big picture, being on a team.
I like how even our silo is social distancing. So we're COVID safe.
We're all in our own silos now. Anyway, from this perspective, it's important to know, what's going on with your product. How is it actually being used out there? And again, figure out what your values are. So I have a story here specifically. I don't know how many of you have seen log statements like this in a product. Steve, have you ever come across stuff like this?
Yeah, so it looks innocuous, but the camel casing looks suspicious.
Yeah, this is just a typical log. I've seen stuff like this a lot, and usually what it comes down to is just it should actually be, maybe a trace statement or even maybe a debug statement. Usually I see developers use stuff like this just to be able to trace a path through the software so that they can tell what's going on. And what I'm going to touch on is observability of your software in production. Well, sometimes there can be a lack of communication or a miscommunication on log statements like this. Logs are pretty commonly used to improve observability. And there was a situation where I was making some improvement to some software, and I moved some things around. I was pretty proud of myself. It was brilliant. The software was more efficient. It was faster. It just worked better. So those were my values. That's what I was after. Well, it went out into production. Weeks later, I get some visitors from upstairs, not to me specifically. This is the interesting part. They come down to our kitchen because we had the better coffee. And these were members of the product team. And they're talking about how a particular service just isn't doing so well anymore. And they're trying to figure out, why customer usage has dropped off, that kind of stuff. Well, I just happened to overhear this conversation, and it perked my ears because this was my service. This is something that I, was working on and developing. So I want to know what's going on. Turns out there were dashboards set up that I wasn't aware of that folks were looking at to monitor how well the service was doing. And by how well, these were business metrics. How many of these operations were customers actually doing? Well, turns out these dashboards were based on a log statement that I knew I recognized immediately because I had moved it. Not only did I move it, but I changed it. So the dashboard was no longer picking up on this log statement. So this is what I'm talking about as far as silos are concerned. This silly
This
log
basically,
statement.
this wasn't a log statement. This was code. This was an API.
Yeah, yes, yes. This log statement was being used to identify when a particular service was being used. And once it was, ripped out of the code base, there was no more metric. Well, yeah, and I didn't even know that there were dashboards that existed that, business decisions were being made like this. So communication, make sure you're communicating with each other. Right, this is a very, very busy slide, but this is a very good detail on the actual steps that you take to get your product out into production. Like I said, we focus so much on the actual final product that there are times when you need to actually go and look at the process and walk through it and figure out, how can I be more efficient here? How can I be faster here or safer here? And one of the biggest things is the whole continuous integration piece. And this is the piece, where you can save a lot of time. And this is basically what has happened to me in the past. And this is one of my favorite pictures. I was in a situation where anytime a developer committed code that happened to break the build, and the problem was you didn't know, you could commit the code and it could fail. And it might not be until the next morning that you come in. And you have to check your email immediately and make sure that all the builds have passed before you actually pull new code. If you happen to pull new code and the build is broken, you're stuck until that build is fixed, until someone checks in a fix for it. So there were a lot of donuts being delivered. We called those donut days. And those were days when you'd come in, maybe you forget to check your email and you download code and it's broken. And of course, the person whose fault it was became pretty famous that day. And there were lots of donuts. And if you can imagine this.
Okay, so you just sync your code and then you can enjoy donuts for a few hours.
Yes.
It's pretty nice.
So this particular problem could be solved pretty quickly by having a very robust continuous integration system. And this is basically, a developer comes in, your requirements here are having source control. I don't know of a team right now that is not using source control. That would be pretty horrifying if you're not. You need that central location so that your developers aren't stepping on each other. And then the other requirement is a build server. You need a server that will build automatically as your code changes are checked in. So we had this, but the problem was we didn't have one extra step. And that was something I was introduced to much later in my career. And that was just the whole idea of a pull request. This whole idea where you could, pull code, make changes, commit changes, but it doesn't actually get merged into the code base yet until it actually passes a build. This would have saved us a ton of donut days. If that build didn't pass, then the pull request would be marked as failed, and that code would not be merged in. And I would know immediately that I needed to fix something to get that build passing again. Seems pretty simple, but I know a lot of teams that are not taking that extra step, and I imagine there are still a lot of donut days going around. So the next piece of our development cycle is the actual build itself. The most important thing you can do is just get to know your build. A build server will do the heavy lifting for you, but I think it's really important for you to understand how your product is actually being built and put together. There are a lot of pieces and parts. It can be really slow, and understanding why that is can make a huge difference in how you develop and how you keep yourself efficient. So, and that specifically from a developer's perspective, know where all of these pieces are coming from. Are you pulling in stuff, over the network all the time, every time you build? Are there pieces and parts that are being put together that maybe you're not working on and there's no reason to build those parts? I was involved in a team for a while where it was a multi-Java module product. And I was just starting on the team, and I did not take that first step to really understand the build. I just wanted to dive in and start working, start putting in my feature. I figured out, what module I needed to work on and started doing that. Well, I would often use, Maven Clean, and this would cause me, every time I made a change, I would rebuild this whole project, and it would take about 20 minutes. That's a lot of wasted time and inefficiency. And it was a while before I understood that I really only needed to build a particular piece of it as a developer prior to checking in, and then let the build server do that heavy lifting and do, the entire product, all of the modules, and then begin integration testing, stuff like that. So yeah, just know your build, know where your stuff is coming from and how it's being put together.
Yeah, but then you missed all your nice long coffee breaks to have your donuts.
That's true. That's true. You don't get much of a break. So this fits right into integration test environments. There is no reason, with all of the resources that we have today, our cloud environments, that we can just spin up temporary use cases, using containers in order to, wrap our applications and our external services into, temporary building blocks, throwing them out there, getting an actual integration test going. We really have no excuse for skimping on that type of thing. There's a lot that you can't do just on your dev box. A lot that you probably, if you consider the risk of something getting into prod that has, an API communication that isn't quite right, or here's a really good one. I was on a project once where we just used an internal database to make all of our database calls. That's what we used for all of our unit testing and stuff like that. And that saved us a lot of time. However, there were cases where the actual database we were using MySQL at the time, it behaved a little differently than our internal in-memory database. So there were some situations that did make it out into prod, where the communication, the database call, the stuff that was inserted in the database wasn't quite right. So there's no reason to go through that pain.
Yeah, I've been there too. That is painful.
Yes, especially when this project needed to, have the capability of using multiple databases and kinds of databases. So that's when things really got interesting. Something like test containers is really valuable for that. You can, spin up a temporary instance. Another reason to do this is versioning. I was on a team once where our development versions were completely different than what was in prod. So that's something to keep an eye on, and using something like test containers can help, lock you in to the actual version that you're using in prod and the actual product or external service that you want to use in prod. Lastly, your actual deployment. I have been on teams where deployment was manual and we scheduled it, and it was, several hours of the day, and I needed to be there as a developer to handle, some of the application problems. This is really interesting to me because I didn't really appreciate what all goes into a deployment until I joined a DevOps team. Prior to that, it was just throw my stuff over the wall and let ops deal with it. Well, after being exposed to all of the steps that are necessary to get your product out there into production, not even just production, into any environment, a QA environment, a dev environment, any of those, I really started to care more about how my application was running, how it was using resources, how it communicated outside of itself. It was a really interesting experience for me. So one of the first things we did on this particular team where it was manual, we just realized that this was a process that was taking us a lot of time. So we just went into a room and whiteboarded the steps it took to deploy. We continued doing some of these steps manual, but one by one, we started automating each part. And eventually we got to a state where a deployment, maybe only took 30 minutes instead of 3 hours. it was a really, really good experience to go through. So
Cool. And it may not have been a deployments which could have potentially cost 400 million, like Knight Capital,
right,
but
right. Thankfully, no.
having an automated deployment process might just save your weekend instead of getting a phone call or being called out on some sort of mistake which was made on a manual process that you have to fix.
Definitely, definitely. Well, that is all I have. I do want to point you again to our JFrog show notes page where we have all of our recordings and slides available and your chance to win the GoPro here. Did you have any final thoughts, Steve?
Yeah, no. So I want to thank all the J4K attendees for coming out and attending virtually. We'll be in chat, so feel free to engage, and if not, you haven't already, ask us questions and let us know kind of how you've been doing with your deployments and your automation and your processes. And we're happy to talk about some of our experiences. And I hope that you guys learned a lot from the conference. I mean, I think the best thing you can do in the current pandemic situation is just improve your skill set as developers, learn new technologies, and kind of grow the skill set, which makes you very marketable and highly mobile. Because we're fortunate enough that our industry is mostly unaffected by the current situation. Well, except we're not on planes anymore. We're just recording and in front of our computer, attending shows virtually at all hours of the night. All right, so thanks everybody. It's been a pleasure, and we hope you enjoy the rest of the J4K conference.
Thank you.